I also need to start the Facebook Live. Give me a couple minutes. I hope you don't mind. You can just say hi to Teams now and give me a couple minutes.
Of course.
Thank you. Thank you so much.
Hello, everyone. Can you hear me? Yeah. Cool.
You probably can't hear them because they need to take the microphone from me to say hi. But that's maybe they don't need that now. And we are ready.
Perfect. All right, we haven't checked the screen sharing yet, actually.
Oh, yeah. So maybe while you're doing that, you can introduce yourself and tell a bit about yourself, and then you can start the presentation. How does that sound?
Yeah, I'm trying to find how to share. Maybe I can send it to you and then you can open it.
Here on the bottom, there is a share sign, like
oh yes,
right on the bottom,
green,
and then you
green,
choose.
Yeah,
it's
the
a
most
one. Yeah.
Ooh.
Uh-huh.
Cool. So my name is Ivan Isakov. I'm CTO and co-founder of a company called Valkyrie Industries. And can you see my screen?
Yes,
Perfect.
yes, we do.
So I will be talking today about special considerations about hardware startups. And I know that some of the companies at your incubators are hardware startups. That's right? How many of you are hardware today?
You can raise hands. So we have one, but we also have teams from Kharkiv, and that would be plus, I would say, about 2 people.
Mm-hmm.
2 teams and about 3 people.
And Andre as well. I can see he's on the call as well. Well, I understand that. So not all of you are hardware. So the first part will be kind of combination of both software and hardware, and what's the difference, and maybe software people will find it useful as well. Second part will be a bit more on product development, and it might be a bit less useful for software, but who knows? I think it will be around 1 hour, maybe a bit less, depending on the tempo, and we'll probably have one small break in the middle. Cool. So, well, first of all, I think we live in a great time. It's a renaissance of hardware. We're seeing everyone just using, creating new hardware startups because prototyping is so super easy. Arduinos, Raspberry Pis, 3D printing, laser cutting. I think Ukraine is, especially Kyiv, is seeing the boom of makerspaces, and all this prototyping community is blooming. So I think it's a good place, especially Eastern Europe and Southeastern Asia.
Stuff will be packed.
Can you hear me? Yes.
Yes,
Yeah,
yes.
I've heard someone. Sorry.
It's someone connected. I will mute them. Never mind. Don't worry. Okay. Yeah.
And the supply chain is great as well. It's better than ever. China, you can go to China and do manufacturing there pretty quick and affordable and scalable. Now Eastern Europe as well getting along together with China. So you're again in the right place. Countries like Hungary, Bulgaria, their factories starting speaking different languages, so you can go there and build your devices there as well. And there's as well more funding. So in addition to VCs and angels, which look into hardware as well, there's Kickstarter, Indiegogo, all the crowdsourcing, crowdfunding campaigns that you can run, and you can get a lot of funding there. So everything just shows that hardware is easy, although everyone says the hardware is hard, but it's getting easier. And so you can see, because of that, you can see the growth of Internet of Things, of robotics, drones, connected hardware, and a lot of wearables as well. So I'm personally, I do work in wearable tech, wearable and VR, which combines a couple of new technologies, both hardware related. And so we're getting to this place where maybe you've seen, some of the companies. So the one on the left is a Fitbit, first wearable tech that grown from a small startup to public company several years ago. The one on the right top, Magic Leap, is actually a bit weird company because they have raised $2.5 billion before showing the product, which is very interesting because usually it's not done like that. And then the company on the top, but the bottom right, is a Ukrainian company, Cube, that's pretty, I think, famous in startup community in Ukraine, and it's in the States. And the company on the left is actually it's other way. It's not a success story. It's other way. They have raised 120 million, but there's with a useless product. So the product that creates juice out of these small packs, which in principle a person can buy a pack and squeeze juice out of it. So they over-engineered the solution but raised 120 million in Silicon Valley. So you can see how the world is interesting. So you can create great devices like augmented reality glasses or tracking technology, but at the same time, the whole field is skewed a bit. So you can find some weird examples, which we don't want to become, like juicer. So yeah, in the contents today, we'll talk about a bit of life of a hardware startup, how it's slightly different from software, a bit of financing, and a bit on product development. A lot of this information that I'm using here is actually based on a lot of online resources by Hacks. Maybe you know it's the most famous hardware incubator in the world. It's in San Francisco and in Shenzhen in China. It's the first and the largest hardware specifically oriented incubator. Then there's Brink. Brink is actually a company that's everywhere in the world now. It's as well started in Hong Kong, and it's now in Poland, and it's well focusing on manufacturing, on helping companies, startups from an idea stage up to scaling and to shipping. And there are a couple of more hardware incubators like Highway 1, more US based. Okay, so the stages. Similar to software, you start with concept, you do some feasibility study, you test the concept with your customers, you check what they need, you find a problem, you find a solution for it, you have an idea and you have a potential solution. Then you do R&D, you source components, you prototype constantly, you do a lot of user testing, so it's a loop process. And after R&D, you're ready to do manufacturing, and then you sell your product, you do retail. It's a much longer process than in software and much harder, but it's possible, and everything is done for that. So concept, same thing as with software. Now the question is actually not how to make something, but is it worthwhile to make something? So you need to focus on a problem, not a solution. In a lot of cases, company comes with a solution and says, oh, now we need to find a problem that this solution solves. And this is not a very good way. The company is usually deemed to die at some point because they're designing the product with no end users in mind. The so-called human-centered design process should be applied here. So you need to find the customer, you need to find the end user, and you need to go understand what this person needs, understand that it's necessary to build this particular product for them. And you need as well to ask yourself a question: is it really necessary to build a hardware product? Maybe you don't need to build a hardware product. Maybe you don't need to redesign something. Maybe there is already a solution out there, but you just need to combine it using software. So there is no need of creating something new when it already exists. It's not necessarily the solution to the problem. About solution looking for a problem is this example of a hammer. If you have a hammer, everything for you is a nail, and it's not a good way. You need to find a nail, and then you need to build a hammer. And another quote that I really like, it's in here. It's don't fall in love with your technology. If you create a technology, if you're a specialist in this particular technology, and you then found a solution, a problem with this technology, maybe it will become irrelevant, but you will still stick to this technology, and this will lead to your failure. So you need to be open to a lot of different technologies. You need to ask yourself, do I need to do this particular solution, or can I make it easier, simpler for the end user? Okay, and you start concept with, for example, you found out, yes, the hardware is really a solution. You start doing sketches, you understand what the features should be, you do the performance requirements, and yes, and you go and speak to people, and you understand what the use cases are, and you understand what would be their target price. You need to understand, will they buy this product, will they not buy the product, and you need to understand your business model. And here, I mean, it's a lot of different types of business models. Of course, it's B2C, B2B, simple ones, and probably you've been hearing about it all over during the incubator already. I'll just mention a couple of times more. Hardware before, it was usually focusing on B2C, but since last, I think, 4 or 5 years, it's been gradually going to business. So investors are afraid sometimes to invest in companies who go to business to customer, and they're going to B2B. Of course, it's everyone, we're doing the same thing. We try to find a large customer that will give us a consistent revenue stream, and this is perfect for both us, for end user, and for investors. Then there is, of course, different type of business models, like razor blade business model, or premium, or any other ones that are risky. But they're important to understand, and to understand how we will be selling this. There's another way. I think one of the companies here at the incubator is focusing more on not on the end device and product, but on the technology. So this one is a licensing route. So you can create a technology. Maybe you need in the beginning to create, I think it's nanocrystalline films is a part of the incubator, right? You know? In Kharkiv, I think.
Yes, it's correct.
Yeah, so I think for them would be to prove the technology and sell it to big companies, and then the big companies will use this technology in their product. But sometimes, in this case, the startup still needs to create some sort of product in the very beginning that uses this technology to prove a point. So maybe you'll be selling only, I don't know, some thin film or some process of creating this thin film, but sometimes you need to show the full product, the full device, how it will work, what it will do. But the other parts are just off-the-shelf components and not optimized. So this is some of the considerations.
Ivan, can we ask here the question? Yeah, that's nanocrystalline. You are correctly said about that. Just a question. So if you have some portion of the B2B device, for example, you're working for the telecommunication equipment, and you have a portion of that telecommunication like a transceiver or radio equipment or something like that, just a part of that. So who has to be the customer with whom you are testing your business model? And do you need to prepare the full scale of the equipment or just some portion of it in case of B2B?
Well, it always depends on exactly. So sometimes you can get a partner that has other part of the full technology, of the full stack technology, right? And you can partner with this company and create the full device if it's really needed. So I think in your case, if you want to go to you said you have a part of the B2B technology, right?
Yeah.
So if you have a customer or if you have a company that you think will buy your tech, you go to them and you try to understand, to get under their skin and understand what exactly they need or what the proof for them will be. So maybe they will be happy with the only part of your technology.
So in any case, the customer is the next in the value chain. It's not the final user. It's the next company in the value chain.
Well, company may be your user. Company may be your...
It's any kind of, for example, you do the energetic turbine, you do a radio-based station, and you do only the part of that.
Yeah.
So who has to be your client? Somebody who is creating the full turbine, full radio-based station, or it has to be the network operator, it has to be the energetic company. So who has to be the client in that case?
Well, so I'm not specialist in turbines, but I think that the integrator should be your customer.
Okay, clear. Thank you.
That would be my first shout. Mm-hmm. Cool. Okay. So you have a concept, you have a business model, you have a fixed features, you have use cases, you have target price, and so on, and you do feasibility study. And I will talk a bit more on this in a second. So this feasibility study will then bring you to technical requirements. So you'll have a product requirement document, you'll have a component selection, the initial bill of material, you have schematics, you have all the list of the things that you will need from your product. So you need to have a very clear and precise understanding of how your product will work, what it will be made of. It's not just random thing, and how it will be assembled as well. The best way to understand where the problems can be. And so this is technical requirements after the feasibility study. So feasibility study needs to bring you to understanding that this is possible. This device can be done, can be created, and it will be feasible. So so in the terms of prototyping, you will be doing prototyping during feasibility study. You'll first create a proof of concept, a device that shows that it's possible, and then you'll potentially create a user experience prototype. If you have a end user, either company or just a customer, consumer, then you want to have a prototype that you can give to the customer, and the customer will say, oh, okay, I like it, or I want another features, or I don't like it at all, or this is annoying, and so on. So when you do prototyping, you need to understand, of course, some people are very lucky and they can do prototyping forever. They're bootstrapping, they have their own money for a year, and they do constant prototyping. I know Dyson, the guy who invented this vacuum cleaner without bags here in the UK, he created, I think, around 5,000 prototypes in his shed. So this is a bit crazy. But sometimes you do need this many. But he's a bit idealistic person. He didn't really work with users in the end, so it's actually counter example. But usually you need to create a small prototype and squeeze as much of it as possible regarding the response from the end user, and then create another prototype. So because it costs time and money, you cannot just do one after another. You need to remember that. It will take some time. Sorry, give me please 1 minute. I'll close the door. Sorry about that. Proof of a concept. Development boards, Arduinos, simple software. This just shows that it's not crazy. It is possible to make. I think company Touch Guide is created a proof of concept. Now getting to the next level. Next level is the user experience prototype. Here's, if you can see the GIF. I think you can see the GIF, right? On the right-hand side. Leap motion controller is maybe you've heard of this. It's a small device that sees your hands and creates a 3D model of your hands. So you can then use it to interact with the with world on the computer, or for virtual reality. Can be put on your headset, and you can see your hands, your fingers. So they started from a big box that just proved the concept. Then they made it smaller, and then they, at some point, like after half a year, they created a prototype that they given to developers, and developers started using and saying, "Oh, this is good. This doesn't work." So essentially, I think with software, you do the same. With software, do the same thing. You give it to as many people as possible, get as much feedback as possible. With hardware, it's more difficult, of course, because it's more expensive to get one. But you need to get one. You need to get as many before even going to the next prototype. You need to get as much feedback. After you have a first UX prototype, you do R&D. You improve your operations. You get final Gerber file, final electronics, schematics, 3D models. This you create a visual prototype. So you do the industrial design. You create how it looks like. It's sexy looking. It's very nice. Different colors, different finishes. Whether it be, I don't know, like leather or whatever. And you can do, and then you create a functional prototype. So it's a prototype that looks like, feels like, and works like the end device. It's made in house probably, but it's really the one that you can give as well to people, and they will think that it's almost a final prototype. So again, step back with the UX prototype. It doesn't need to be beautiful, but people will think that it should be the final one. So unfortunately, you will create one, and you need to get as much feedback as possible. But a lot of people, for example, people including investors, will think that this is the final prototype. So look at it and think, it's ugly. I don't want to buy this one. So this is a problem, but at the same time, it's not important that it's ugly, because you want to get the functions from it. Whereas this one, the functional prototype, is the latest version. It looks like it will be final. It's just only small tweaks that will change in appearance. So yeah, visual prototype is just a piece of plastic, but it looks like the last device. And yeah, functional prototype. Here, actually, on this image, you have both the. So this is it's a watch. It's a modular watch. On the right-hand side, it's a prototype that works like the last one. So it's a works-like prototype. So it works like, but it's much larger than it should be. Whereas on the left-hand side, it looks like and feels like. So they're two independent prototypes, which then will merge together. So it's another design approach. You can work independently on works like, independently on looks like, and then merge them. Again, if you look at the Leap Motion, the last one, I think the first developer unit, or like the August 2012, they're the devices that are ready to be shipped, ready to go to factory. And then another important thing is the manufacturing. Here's a quote, making one thing of something is quite easy, whereas making lots of something consistently, which is going to last, is extremely hard. Because that's manufacturing is completely different part of the development, of the hardware development, which software guys don't encounter, which is good for them. At the same time, everything around us is hardware. So all of the things are made in factories, and it is important and complicated, and a lot of companies die because of problems during manufacturing. And here as well, you start working with a contract manufacturer, with factory. Your factory becomes your partner. And this is important, to be a partner with the factory. It's not just someone you give work and say, do this. You work together. You engage the factory to do design, called design for manufacturing. And then you iterate, and then they say, okay, we can create that. They do first factory run. You spend a lot of money on that, on the tooling, on engineering costs, and then only you can start rolling out tens of thousands of devices. So yeah, salesman prototype is pre-production. It's just before certifications. So you'll need to do, as well as your hardware, you will need to do, if you're going for a product, not licensing, if you're really selling to either to businesses or customers, you will need to do certification, testing, and so on. This is the prototype that you'll need to create. So again, concept, proof of concept, user experience prototype, visual prototype, functional, salesman, final product. Time frames. Larger than software, but can be reduced if you're in a place which is great for prototyping. For example, if you're in the very beginning and you go to Shenzhen, stay there for 3 months to half a year, you can create same thing you do in Western Europe in 1 year, like 4 times less. Unfortunately, I'm not exactly familiar with the prototyping scene in Ukraine and in Eastern. I know in Eastern Europe it's great. A lot of engineers there that do great job. Still, they outsource a lot of PCB manufacturing to China. So sometimes there you can get suppliers, you can get manufacturers much faster. So if you're creating a product, or if you know that you will have a long R&D cycle, maybe going there, it will save you a lot of money and will save you time as well. Manufacturing as well takes a lot because you need to go with suppliers, certification, contract manufacturers. It as well can take from 3 months to 2 years. And yeah, retail sometime. Okay. Financing. Again, these are numbers, approximate numbers. It's not, I think I should have said less than 50K. They're different from software and they're approximate. So concept, you just think, you do research, customer development, you don't need any money. Proof of concept is, I think, less than 50K. Maybe sometimes you can do proof of concept much cheaper. If you have a good engineer, if you have a lot of devices around, if you make a space, you can prove principle pretty cheaply. Then for functional prototype, yeah, usually it takes a lot of resources, 50 to 200K, to create a product that looks like what it's like. Design for manufacturing as well, tens of K. You can get it to 50K to develop the design itself. Even before doing any manufacturing runs, you already need to spend a lot of money for creating design for manufacturing. And as you see a couple of quotes on the right-hand side, well, first of all, prototype is ready when it can be manufactured. So when you say, oh, I have a prototype and it's ready, and you go to factory says, no, it can be manufactured because it's, I don't know, thin walls, or it's a lot of small parts which can be plastically molded or anything like that, which is super important to understand in advance. And yeah, another thing, no hardware plant survives contact with the factory as well. It's just good to understand in advance and understand what will be your timing, be realistic. And then you do first factory run. Even first factory run is already pretty expensive because you need to do tooling at the factory for one device. And it is a good time to doing crowdfunding. So if you already created design for manufacturing, you have a product that you can manufacture, you can do that. And then you do crowdfunding, and then you get a validation of the market. So if you have, 200,000 raised, you say, amazing, this shows that there will be a lot of people who wants to buy my device, and you can go to investors. Investors will give you $1 million more, and you can do not just first factory run, but do a proper retail already from that. And this is again, so this the funding routes, the founders, friends, family, fools in the prototyping early stage. Then you go to accelerators, angels. For production, do crowdfunding, pre-orders, and then this very difficult part for hardware startups when you do have devices, but there are only 5 people who bought them, or only 100 people, and you need to go from 100 to 10,000, and this is called the bridge of death. Not many startups go through this, but then if you go, you get VCs, banks, and so on, and you maybe steady state company which is perfect for you, and you can IPO, whatever. This is slightly different, but yeah, similar thing, but it's more about technology, how technology is regarded by the public. Again, and you can combine this with the funding. It goes first to the peak of inflated expectation and goes down, and it can go down, especially when you start selling, to try to align both of these graphs together so that you wouldn't die at the disillusionment. Because at disillusionment, no one wants to invest in you. But if you have already devices and you have customers, then you can go to the slope of enlightenment and be productive and steady state. I'm saying a couple of times here, I use the word steady state. It's a lot of VC funding or angel investment funding, VC mainly, is looking at getting 10x return, right? So you go to VC and the VC say, oh, if I invest into you 100,000, I hope that I will get $1 million back, or whatever, 10K return. That's the usual rule for VCs. It's not necessary for everyone. It's you can be a company that's just goes steady state. It brings steady revenue, steady. It doesn't need to be 10x. It can be much smaller, and it's your choice. But it's just good to know different. Okay, so for production scaling, if you already get to the almost point of the production, if you're going with a factory, there's several ways you can get money, and VC is not the best actually. Well, first of all, it's pre-sales, so you sell product to customers that would like to buy your product, or you can get credit from a supplier, or you can work with manufacturer, and manufacturer can give you some money and get together with you income. Then there's another thing called purchase order financing. If you're a B2B company and you go and you have a customer, a big corporate customer that says, okay, we'll buy, I don't know, 100,000 devices or devices from you for, or maybe less, whatever, for 1 million. And they say, and this is a contract. We can buy this for 1 million. And you go with this contract to a bank or to some companies that do this, and they say, okay, we'll support you with manufacturing. So if you, for example, for manufacturing need 100,000, your purchase order is 1 million, and bank can support you, I don't know, 70% with very small percentage. So you can already get almost all manufacturing even without any investment. So all the money stays with the company, and you're growing as you would grow with VC. So it's perfect for startups if you don't want to lose part of your company. Cool. So just some recap. You need to understand your market. I mean, it's obvious to know your customer straight away, and that's why you need to do a lot of tests, user tests. You need to manage expectations. Again, with the technology, this heightened expectation may kill you as well, because everyone thinks, oh, you're like, you know, with AR or VR, AR saying you can get completely simulate the real life, but actually no, you cannot. So you need to manage it. And so don't oversell, and you need to be clear as always with your clients. A couple of words on traction for hardware. So investors like traction, like to know how many customers you have a day or a month. For services, software as a service startups, is pretty easy to quantify. It's difficult to quantify for hardware startups, especially for those who haven't yet shipped the product, right? There's no way to measure. I mean, you don't know reaction. So that's why you need this user tests. If you have a user experience prototype and you're trying to find how to measure the product experience and to ask for the feedback. And if you're B2B, then try to get to network as aggressively as you can and get letters of intent with customers saying, I would like to buy this product. And this is your traction for hardware. So how to measure user engagement? You have solid functional prototype that users can engage with. Then to understand how to quantify this, the engagement with this certain prototype. Then try to focus on minimal feature set. So if you try to build everything straight away, which is not very good, it's worse than if you have something one specific that specifically works, that people will be happy with, that works. And perform interviews, or you can get written feedback or record the users. And there's one good net promoter score, so-called. So after the feedback, you can ask on the scale 0 to 1, how likely are you to recommend this product to your friend? So if a person will recommend this product to their friend, it likely means that this person will buy the product as well. And it's not actually just gimmick. So it's not just for investors, it's for you as well. If you're growing a company, you need to understand your customers. So you need to track their engagement to understand, because maybe you're going somewhere completely opposite. We are building our device. So we have a tracking device. It's a glove. And sometimes when we do user tests, and it's not just tracking, it gives you feedback. So when we do tests, people say, oh, when we did some initial tests, people say, oh, I like to see my hands. And they didn't say anything about haptic feedback, which is the touch sensation. So we're thinking, people like seeing their hands, but they didn't care about haptics. So we're like, maybe we need to focus a bit more on better tracking. So it's good to understand, track the traction. And yeah, and as well, early investors don't need huge amount of data. But for hardware, you just need a very good story with a bit of data, which is believable and exciting. Is it break? Time for break? How do you think? 5 minutes, or you would like to continue? Okay, have break for a question.
Probably some question, Ivan, or
yeah, I'm happy with
anybody from Kharkiv, do you have any question? Or I saw the one question was in chat from Andrei. If you can just pop up the chat question, so you can see in the line below one question from Andrei. Or comments, I don't know that it was a question or comment. Chat is below. If you can put the mouse down so you can see the chat, and that's one question from there.
Trying to find it.
By now, the question from myself, probably it is about the first part, the customer engagement and concept. So how to, yeah, that's one. It was a comment. Andrei said that it was a comment. It was some comment regarding investment.
Mm-hmm. I didn't find it.
It was about 3x return and 10x return in Europe. I guess that was a comment from Andrei about the returns of investments, that the USA acceptable is 3x and in Europe it's 10x, something like that.
Cool.
As I remember, yeah.
Yeah, probably.
Yeah, my question is about the financing model, and you write the concept is zero financial needs because the research in customer develops is zero. So I fully agree with you if we are talking about the customer devices, but if you consumer devices, but if you are talking about the devices for B2B, devices for government, how you can do zero research? So I just would like to understand that. For example, you do one more time, you do the networking for, I don't know, energetic network, for telecommunication network. Can you do that zero? How you can do that then?
Well, it's hustling, I think, more. It's, yeah, I understand. I agree that sometimes it's, of course, finances helps you do the research better. But the thing is here, you try your network. That's the best way. You do start from cold emails, cold calls to people, go to conferences, try to speak with everyone. I think that's the way that's the hustling. I mean, I've just put zero because it's minimal. So if you can in principle do that, sometimes it's difficult, but yeah, it's possible. If it answers your question.
Okay. And so you said the proof of concept, then I just would like to understand on which stage. So what is the trigger when we can move from one stage to another? from the concept stage to the proof of concept, from the proof of concept to the functional prototype, from the functional to DFM? Because usually it is the expectations to improve constantly. So
Mm-hmm.
what is the principle, how we have to decide that, okay, that's a final stage on that level and we have to move further? Because clients usually said, okay, we would like adding that, and it would be nice if we can do that, and so on. So what is your recommendation there?
Well, this thing is average. It's not like rule that's 100% true. It's different from different one, but it's on average that's the way. If the customers ask you, there's sometimes there's a problem over optimization for certain customer. It can be a problem if a customer tells you, oh, I want this, then I want that, then I want this, then I want that, and then you just continue improving, then you risk going only for this customer and not for anyone else. And sometimes it's fine. For some companies, it's fine. You just have one customer and just leave from this income forever. But I think for a lot of you is being more like a platform or going scaling. It's important, more important growing. And for growth or for scaling, you would like to leave other customers still on board. So if some of the customers saying we want this and we want that and we want this, then you just say no. We have another customers. Another approach would be as well, if you, for example, if you find a customer and you show this customer like the best of your features, this feature works, and the customer says, oh, we're happy with this, but we want this and that. You try to get a contract from them. Mm-hmm. So if they're happy with this, what they have, or try to sell them at least part of it. Well, I mean, it's not the answer. It's not answering how to go from feasibility to DFM and so on. It's more how to deal with certain customers. However, if you're going from concept to functional to so on, you do need to plan this in advance, more or less. So of course it will change. You will change this, but you need to know where to stop. And so, okay, we will do these features. The problem with a lot of features is your engineering team will be unhappy, or some other customers will say, oh, we wanted these 2 features 3 months ago, but you're trying to deliver us 5 more features and we're delayed by half a year. This will make them unhappy, will make your engineering team unhappy. So you do need to have a hard stop.
So Ivan, from your point of view, so what is your recommendation to have that time frame, or roadmap where we're stopping and moving to the next stage based on timing, based on cost consumption, or based on limited feature which we set up on each stage? What is better from your point of view? Or it's a consolidated, integrated parameter, or what is?
It is definitely compromise. Maybe you think that we need this, but we don't have money to develop it. So if you don't have money to develop it, then you will not be able to do that. So of course the costs is super important. So yeah, I cannot answer your question straight away, like this is the best way, because you need to you always compromise.
Not just interesting how usually the hardware startups is doing. So they have a roadmap in front. I mean, before they started, they decided, okay, in 3 months we do that, in 6 months we do that, and exactly at that timeline, so they move to next stage. Or it is until they finalize with that, like a minimum 3 feature, they are not moving further. So what is the better, step-by-step approach in that case?
Well, definitely.
My experience is that when you do the hardware startup, and you have quite enough money, not enough, but intermediate money for developing. So you constantly change business model, you exchange the device, so you're improving constantly. Then somebody is coming to your startup suggesting, then advisors giving you new advice, then the customers are putting some new expectations from the features. and you never stop. You're just coming to the first stage and then coming back and then
Yeah,
you cannot move
iterations.
further. So that's
Yeah.
why my question is how to really decide it and who has to decide and what can be the better, the reasons why I have as a CEO, for example, of that company said, guys, stop on that level, move further. So what is the best experience from your point of view, where we stop and go moving forward?
Mm-hmm. Well, in our case, I think although we have a lot of features that can be improved, and like my personal, we did write a list of features that we need to finish without any changes. We do have customers with whom we're aligned. They given us the list of their features. We combine them with our features. We understood that maybe this we can negotiate with them. This we don't need for some other customers. For example, this will be over, again, as I said, over optimization. So we found a compromise to say this will be our plan, and we try to go according to plan. Then with hardware, in a lot of cases, you'll have some delays. Suppliers, manufacturers, just R&D in general. So you do have delays. You need to plan for contingency, definitely. But if you have a certain number of features, I think, you are the company directors, and you say this will be our. This uses your company, so you create these rules for yourself. But you need to understand, of course. You need to understand in advance. I agree completely with you. You do need to iterate always, but you do need to say sometimes stop. It's fine. We need to go further.
Mm-hmm. Okay, thank you. Anybody else would like to ask some questions?
I have a question.
Andrei, yes, please.
So if you are a hardware startup and you found R&D company which help you to develop your product, and how to manage them. So the question is how to be in time, because there is a lot of cases when R&D companies start to work, and in your case, in your slide, you show that R&D work starts like from 3 months and it could be like 2 years. And the question is how to manage that R&D companies that they be in time on what they promise to deliver. So is it to have some like experts, like third party, like one guy from not from your team and not from like their team, like third party which will give some advice or every day to call to them. So what's your advice? What to do in this case?
Cool, thank you. Did everyone hear the question?
Yeah, Andrei, let me
I did hear the question.
because we have a really bad sound from your side. So to my understanding, Andrei is asking that when he's doing the already prototyping or production even together with R&D company, and the R&D company become the part of your team. So his question is how better to manage that R&D a team together with your team. What is the best evaluation principles or tracking principles or controlling principles? If it is right, Andrei, please say.
No, it's not right. So my question is, so in our case, I will explain even more simple.
Better write in the chat.
So you can't hear me?
It's a bit noise.
But can you hear me or not?
Short question. Can you provide short question? Well, I can hear Andrei, and I think I thought it's a similar question about R&D company that you outsource some R&D research.
And they are not in time. What to do?
Well, if they're already not in time, that I don't know, you cannot do anything. If you don't have anything legally binding, I have a couple of slides later, but I can tell straight away. So one of the thing is you need to try in advance to understand what will be your communication protocols, and if they're already late and you don't have any legally binding documents, then I don't think you can do anything. I mean, you can try to negotiate, saying guys, I know you can try to make them do something faster and saying, oh, okay, we will give you some bonus if you make it something faster. But if you make something slower, we will need to cut some of your some of the money that we need to give you in the end of the project later or less. But it's negotiation, because if they're already late and you don't have anything in place helping you, then I don't think there's any way. That's why.
Is it some kind of SLA agreement, service level agreement in front?
Yeah. So you need to have something in advance. Yeah, like quality. Yeah.
Sure.
So how do you call it? So yeah, what sort of quality they do need to bring? How much? What will then? How this will affect the prices that you pay them and so on. But of course, with R&D, it's very, very difficult because it's R&D. It should be run on flexible management terms, and the best way is to try to make them part of your team. So not like in get them in your office and manage them as part of your team, but you're very, very closely communicating with them. So the communication is like the key. So you need to have with them constant communication, one channel of communication. We actually had some problems. We had like 3 different channels: WhatsApp, Slack, and emails, and this was in hell. Try to get one channel of communication. Try to have, I don't know, maybe 2 weekly. Depends on how close you are. You can have weekly with communication with them. And then if after a week, so first of all, they give you Gantt chart. So they give you a list of how they will create, how they run this project. And then after every week, you check according to this Gantt chart and understand, okay, they're already late. What should I do because of that? So you need to understand and maybe remove some of the features that you don't need or something else. R&D is difficult. It's especially R&D companies, they like doing R&D. So they'll happily sometimes postpone or delay because they're having fun with their project and they're experimenting. But yeah, having everything planned in advance is the best way. But if you're already late, then I don't think there's anything you can do.
Mm-hmm. Okay, thank you, Ivan. So I propose to do the break now. Can we hear later after the break the more details about documentation which has to be prepared for the hardware? Because the Kharkiv team is asking about the some kind of more detailed documentation which has to be prepared together with the hardware prototype, to my understanding.
I think I will. It's like for factories, you mean, or for product requirements.
Documentation for prototype and product.
Yeah, potentially. I think that should be somewhere
later. Okay.
Mm-hmm.
So how long time do we need the break now? 5?
Like 5 minutes.
10 minutes, Ivan. 10 minutes.
10 minutes.
It's okay. Mm-hmm.
Yep.
Okay. Thank you, guys. Thank you.
Не полезен, ну просто релевантно на самом деле, но он интересно все равно рассказывает. Ну просто может быть зачем сейчас?
Да. Это надо
чекать. В целом, типа, ну, например, в моем случае я могу пойти там пообщаться с тем, что реакция, стало интересно, да. Я вот хочу Марка организовать на производство. А сейчас
Я думаю, что надо его больше спрашивать с точки зрения инвестора.
Да.
Все-таки
Вот
он
это
очень
был
близко
вопрос.
к инвесторам, вы просто как бы, ну, можете смотреть смещенно немножко тем. Что видите, я тоже задаю вопросы, ну, то есть мои темы, я занимаюсь там большим количеством там, телефонов, стартапами, и это оборудование, конфермы, да, там, передачки и так далее. Поэтому он не может ответить на мои вопросы, к сожалению. Он работает с консюмерским рынком. Ну, а раз он работает с консюмерским, то с ним тоже работает. Поэтому можно спрашивать, это одни и те же инвестора.
Кажется, что как раз инвесторов, которые хардвер в том рынке, те, кто с продуктом.
Консюмерские все оборудования. Так что, ну, консюмерские инвестора, это просто физические лица, да, там, ну, венчурные фонды и так далее. Те, которые инвестируют большой объем рынка. А хардверные инвестора, это конкретные стратегические компании, большие дороги, машиностроение, производство, Sony, BMW, Mercedes, корпоративная форма. Ну, в общем, я имею в виду, что вы не стесняйтесь, спрашивайте, может быть, после. Он в Англии сидит, там, значит...
Он вообще русскоговорящий?
Он же потом говорил, что
слишком
их
у
стартап как раз для VR-технологий, для гейминга очень подойдет.
Я просто хотела сказать, я на русском 3 слова. Но он какой-то третий поколение.
Кем? С Иваном?
Да. С этим русским Иваном. Понимал? Не, ну я не знаю, думаю, Харькову было бы интереснее по-русски то все услышать. Ну да ладно.
Ну, они же не молчат, не говорят.
Молчат они сидят, молчат. Им все понятно, говорят. Нам, говорит, все понятно. Нет, не просто так
а можно сначала там, где
вопросов нет, говорит, все понятно. Да. Ну, как будто рынок маленький. Да? Не, нормально вас. Я как-то вылечил тоже. Достался.
И вообще, прям список подготовлен.
Я помню, он говорил,
Деньги на них не заходят. Да, я просто один раз перевел. Тебе выставляют счета, на которые тебе нужно пооплачивать. Это отдельно имущество, кто владеет имуществом. них есть просто за их услуги ты платишь отдельно. Это не то. Там больше
Should we recommence?
Hello, Ivan. Can you hear me?
Yes.
Yeah. Okay. So we can continue. And so the floor is yours.
Perfect. Cool. This probably should be shorter. All right. So this is the slide from Hacks Accelerator. It's a good one. These are the three main rules for a hardware startup that combines a lot of things, both the product development and a lot of other things. So one, when you design hardware, design it with the right components straight away. So the earlier you start to write components, the better it is. You don't need to redesign anything. You need to have a universal components that will be used for some time, that supported by big companies, and they have a big community, for example, that can as well help you with support. So do the right components. Then again, if you're going to do manufacturing, then the prototype is ready only when it can be manufactured. And it's important as well to reiterate. I think I mentioned this already. And your factory is a very important partner. When you start manufacturing, it's important to have a manufacturer as your partner, not as some extra, which is not important. It's not every product can be made in a toy factory. Your factory, you need to get them on board so that it can work for you as well. It's not just a third party in between. It's your key suppliers, and it's very important to have them on board. Sometimes you can even share with them some income or have like two-directional support. I mean, there's a lot of different ways you can engage with the manufacturer, but it's your important partner. Then right business model. If your business model is just hardware sales, your business will die. So you need to go as well, work on software, do some additional parts, do hardware as a service, software as a service, everything combined. It's important to understand your business model, although it will change from a first understanding, but it's not just hardware sales. And be memorable. I mean, it's correct for all the startups. You need to be known by who you are, and people would need to understand, to remember your logo, or first step to create your brand, to be memorable. It's a slide to coming back from a break. Just important things, not only for hardware startups, but some of them is for software, obviously, as well. Cool. I will talk a bit about product development, about approaches and issues. So maybe you know that, but 9% of all the funded Kickstarter projects fail, and 80% of all the funded projects are delayed. Why? Because they need to manufacture something. So it is a problem. Everyone, even so, Andre asked what to do with R&D companies, and I mean, you have delays everywhere. If you're hardware, you will have delays. That's truth. You need to understand that you will have delays. You need to raise money, understanding that you will have delays. So if you think your line in front of you, like you think in 1 year will deliver you get to a certain milestone, get money for another half year, because you might get there and you don't want to live without any salaries or pay just for your engineers. So understand that. So yeah, why is that happening? Mainly, well, not only because it will delay. There's another things that you can start doing now to reduce these delays. One is lack of certainty regarding functions features. A lot of companies just don't know what they do, and they change them. They change requirements. They create new requirements for themselves and for manufacturers. They overpromise a lot and don't align with the engineers, as I mentioned already before. And they try to do multiple approaches at the same time, do not focus on one thing. So that's all brings to delays or failures. So everything is okay. Now more into details. So what is the product development work stream? What are the parts of it? You can, in principle, divide this by 5 parts. There's industrial design, how it looks. Probably I can, for example, have a phone here. How it looks. Mechanical design, whether there are moving parts inside. So there's like haptic motor that moves somewhere, for example, here. Electronic engineering, all the PCBs inside. Firmware engineering, how the PCB, what's the software inside works, creates some lights up and down and so on, firmware anyway, and the software, of course. And all of this is super interconnected. If you are developing a hardware product, you need to understand that it's interconnected and plan accordingly. So this is, well, ideas again. The industrial design, mechanical design, electrical engineering, firmware, software. So industrial design is very much connected with mechanical design. You definitely need to, they all interconnect. If you have mechanical design, some moving parts, and you don't understand that industrial design cannot work with this, then you're screwed. Then electrical engineering affects industrial design as well, because you will have certain MCUs, certain chips, or certain components inside that will change the size of your PCB, and the size of the PCB will change your industrial design. So you may be, your engineers will be developing amazing, very nice, sleek looking like a device, and whether it will be, you know, for example, a watch, a smartwatch, but your engineers are creating some electronics, and then they need to change one component, and because they change component, the size of the PCB changes, and all the things that industrial designer were working on just completely goes into the bin. So they need to be a constant interaction. And the same thing with the electrical engineering and mechanical design, because they will connect as well to each other, and you need to align them together. Obviously, electrical engineering and firmware, they're interdependent. So the firmware will depend on what parts will we have in your PCBs, and the software, whether it's connected to your phone or connected to your computer, or they have a screen or anything, then you need to have some interaction there as well. So some companies have only parts of this graph, some have everything. Okay, yeah, and there's you can find online some Gantt charts or showing how the industrial design interacts, at which point you need to bring them together. Just before, for example, before user experience prototype, you need to bring all of them, mechanical, industrial, and electrical engineering design together to create the last prototype. Then you can again split them, and then you can re-engage them. So everything is interdependent, and beware of that. Now, a couple of things about outsourcing. I don't know, this slide, I think it's a bit messed up. But anyway, it's for Andrei's question. So again, this triangle is pretty famous, I think: cost, speed, and quality. If you're outsourcing some of your work, you cannot get all 3 of them at the same time. You either get quality and speed, but it will be super expensive, or if you want to reduce the costs, then you either reduce the quality or reduce the speed. So there's no way you can do 3 of them together, which is important to know. So be realistic always. And the thing on the side I mentioned during the answer. So communication is crucial when you're outsourcing. Trying to use one communication channel, and flexible. If it's R&D, for example, it's trying to get flexible management plan and try to bring them, your companies, close together, so that they feel that they're part of your team, so they can they will want to deliver as early as possible. Sometimes R&D companies, they even get they sometimes have a contract with you, and you give them 1% of your company to deliver something, and they work for it much more than they would be if you wouldn't give them this equity. But it's again up to you to decide. Supply chain, there are 2 parts. So there's you in the middle, and there are suppliers, and then the contract manufacturers. So there's a image on the bottom right showing how you create an Airbus and what parts, where do you construct it, where do you construct parts, how do you logistically control them. They're everywhere in Europe. And this is very important to have a very precise and detailed understanding on who's building what at which time, what are the lead times. This is very important to know when some parts are coming there so that they can be assembled from suppliers to manufacturing. Question about China. Do you want to go to China for manufacturing or not? It is quick, but it's still not less than 5 months. So it's still long, and it makes sense only for high volumes. Eastern Europe getting better and better, so you can definitely do a lot of prototyping there, manufacturing, slowly getting there as well. But at the moment, still China. Again, coming back to the lead time. So if you have suppliers, you need to really understand, and manufacturers, you need really to understand what's the lead times, how long will you need to wait for supplies to come. So for example, for manufacturers, the tooling is creating this tooling for your plastic molding, and it's 2.5 months minimum. So if you overpromise to your investors or to customers, then you're screwed. You need to not to neglect lead time. And for supplies as well, you can get electronics for some special components 4 weeks. So it's very important to understand that this in stock, and these supplies will not deplete in the next half a year. So, and a bit of on quality control as well. So this is quality control for manufacturers, but it can be used as well for your suppliers or for outsourcing. So you need to have some certain procedures to ensure that products or services adhere to certain criteria. It's incoming quality control. So if you get supplies for someone, you need to understand like at least this should be plus minus 5% or whatever the quality criteria is. In process, during the process, you need to control, and when you release your product to or your parts to manufacturers or to end users, you need to have control as well. And then you have this acceptance quality limits. So quality level that is the worst tolerable. For example, again, if you outsource something to someone and you get, I don't know, 100 units from them, then you need to have these quality limits outlined in your initial contract. So in order to try to reduce your delays, you can get this acceptance quality, either quality or as well timing limits. Okay, so this is a bit further down the line. If you have all the functional prototypes and you will start designing for manufacturing, it can be thought that it's down the line, but actually, ideally, you would like to start designing for manufacturing earlier. The earlier you do, the better it is then to adapt your device for manufacturers. And this is again called either DFM, design for manufacturing, or sometimes DFX, where X stands for manufacturing, assembly, environment, disassembly, maintenance. You design your product with something in mind, with assembly, how easy it is to assemble your device, or disassemble your device, or maintain your device. Sometimes you can, like there's a very nice YouTube channel called, I think, I don't remember how it's called, but when they take a device and open them and look what's inside, how they work, and they take the iPods, the iPhone, these earpods, and they open it and they look how they, is it possible to do maintenance with them, or to assembly or to disassembly? And for these devices, for example, completely cramped with electronics, and it's almost impossible to maintain it or disassemble it. And ideally, you do want to be able to get the device, open it, change something, put it back, and send it back to the customer. You don't want to check it out. Sometimes for environment, for example, as well, it's important. But even though you're not manufacturing now, you will manufacturing further. So you need to understand even before to do this design for manufacturing for assembly. And there's several points which are important and which we use definitely in our process as well. So you try to reduce the total number of parts. So you use some of the parts to do two, for example, to do both a PCB can be as well a structural unit. So it can be some structure, part of structure, or part of mechanical holding part, for example, or some other things. You can remove some unnecessary parts. Obviously, it will be less purchases, less handling, processing time. Then you want as well to eliminate secondary operations like welding, soldering. For example, use snaps instead of soldering, or use. Then modular design is very important if you want to inspect independently, test independently, or change some parts. In our case, we have a sleeve glove solution, and the glove is independent of sleeve, so you can modular remove the glove and put another one in from, I don't know, third party, for example. It gives you versatility to redesign at the same time. Then try to use as many standard components as possible. It's obviously less expensive and reduces lead time. If you have a million of them, supply have a million of them, it's better than supply has only two, of course. And as I already mentioned, parts to be multifunctional, and avoid designs that require fasteners, so the screws. Snaps is much better. And minimize handling, so the potential errors in putting them together. So the easier it is to assemble, the better. And this is very good design practices. Choosing components. This is mainly for electronics, but not only for some other design, mechanical engineering as well, for example. So components need to be universal. The more often you find them outside, it means they're supported by community, by wide community. If you buy a very latest component, it's not necessary. It will, if no one has tried it, maybe it will. The company will stop producing it in half a year, and it's already in many of your devices, and you cannot really support them. Then you, of course, performance cost ratio. You need to look at that as well. If it's easy to purchase, what is the lead time you mentioned? Is it sustainable? Which means whether the supplier would stop producing this component. Is it replaceable? So a lot of times the supplier, when they create new version of the component, they have the same size, the same part size. So it's easy to replace it later. If you have very weird shaped component, then it's almost impossible to replace it. And again, upgrade compatible. And if you have a component with 20 pins, try to use all of them. The more you use, the better, of course. So utilize it maximum. These are several rules which you need to, when you create bill of material, when you understand what your components are, look at them. And but of course, it's all about compromising, as they already had a couple of questions, and there's no one answer. Of course, you need to compromise. Depends on your business model, product life cycle. For example, if your product is only after half a year, you can throw it away. For some reason, you have this product, right? Then you don't mind if the components will be removed from a factory, from a supply by your supplier. So you're fine with this. But if you have a long product which lives for 5-10 years, that you want it to be maintainable and which uses the same components that will be used in 3-5 years. So when you prepare your create your bill of material for manufacturing or for next level, then prepare your preferred component list. So first of all, do bill of material, create the list of all the parts that you want, but then you can have a preferred component as well. So maybe some of them will not be able to be used. A lot of times manufacturers, they have their preferred suppliers. So you go to manufacturer and you say, this is my list. And they say, well, we don't use this supplier because for some reason, I don't know, maybe there's China and the States, they in this trade war. So some of the suppliers don't sell to another supplier. So you need to have some other secondary supplier for certain components. So that's why I try to add 2 options for each of your main components so you can exchange easily. Oh, actually, I think that's it. think, oh, that's it. I finished my presentation. There's some other things that I can mention, but so I think it will be better for me to, I think, to listen to the questions. Yeah, these are a couple of sources that I think I will send you the presentation so you can have a look later. The second part was much faster than the first one. I'm happy to take questions.
Some questions, just
Ivan, hi. Tell us, please, more details about your expertise in fundraising. Yeah, what kind of fundraising did you have? What funds, what ventures do you know? Do you work with? Some more details about this, if you can tell us about.
Well, we work in London, in the UK, and we have one angel. We have several investors. Some of them angels, and one VC from Australia. The first prototypes that we did were on the funding from the government, UK government, and a couple of angels. It's called, I can tell you, Startup Funding Club. I think it's on Crunchbase as well. I don't know if they invest in outside companies, but there are a lot of VCs and angel groups in Europe, and I think there are even some documents out there somewhere on the internet, some Excel spreadsheets with all the companies that invest in the hardware, software, and you can just go through them. We started with the UK because UK is a very good space for startups at the moment. So we just go one after another. We try to find either warm introductions, or if we cannot, we apply if they have application forms there, or go to events. But it's UK, and then we got into Brink. So I mentioned this accelerator in the beginning of the presentation, called Brink.io, Brink Hardware Accelerator. We went through that program and were supported by the venture capital firm. So that's my story.
Okay, thanks. You say that UK is a good place for startups. You mean for hardware startups, or every types of startup software?
Every type.
Why there are a lot of ventures, a lot of angels, or maybe other difference?
Yeah. So there's the best one is US. Silicon Valley, US is the best in terms of venture capital. Of course, there's much higher competition, but at the same time, it's much more of them. Then in Europe, it's UK, which is largest for some reason. There's very big startup scene, and because there's a lot of startups, and actually government really helps as well, both investors and startups. So it's a very good ground for us to grow, and for investors as well. So yeah, there's both VCs, angel groups, there's City in London. There's a very big financial center. So a lot of wealthy people who wants to invest now.
Did you have UK registration of company, or this is, if you have it, if you had it, it is important for funds and angels or not?
So we do. We are a UK company, UK registered company. For funds, actually,
in UK?
Yeah.
Okay.
Yeah.
It's important
for many angels, yes. For VCs, no. For angels, I can tell you why. Because as I said, government helps both angels, local investors, and startups to raise money. So it gives some tax reduction to investors, to angel investors, if they invest in the UK companies. So they do want to invest in the local companies, in the UK companies, and they get reduction of their taxes. Mainly, I don't know, about 85-90% of all the angel investors in the UK, they invest in UK companies.
Okay, thanks.
About the numbers of Kickstarter that failed to deliver the product, that it was something like 6%. Does that mean that the companies that won, that received the funding, they failed to deliver 6%?
Yeah. The successful Kickstarter campaigns didn't deliver, so 8%.
And like on average, the whole marketing thing in Kickstarter and everything, like from your point of view, like what is the average of the entrance tickets, so to say, to make a successful funding round within a crowdsourcing organization?
Actually, Kickstarter website, it has very good statistics on how many people raised what sort of money. Usually, I think.
I mean, from the marketing point of view, still, like if you enter Kickstarter, you still have to have that marketing stuff around, that hype, that viral marketing and so on. Like, is there some kind of like an entry point? Like if I have $25,000, I go to Kickstarter to raise like something else, or I know it's on average.
Well, I don't know. I cannot answer this. So okay. Our product at the moment, it's more B2B. So we would not focus on Kickstarter. Maybe in 2-3 years. So I don't really have experience there. So. Okay.
Yeah, just some questions from Kharkiv. Do you have anything? Guys from Kharkiv. So the question to you, Ivan, was from the Kharkiv team. It's about when we do the the manufacture. So we are, first of all, we are producing a prototype, and then we move to next stage. What kind of documentation they have to prepare in the middle? So in between the prototyping and the manufacturing, it has to be how it has to be looks like. In addition to the, so we already have a prototype, and then we try to move to manufacturing. What kind of intermediate documentation has to be prepared?
Yeah, so it's called product development, product requirement document, PRD. You can Google it. It's
product requirement document.
Yeah, it's good. It's description. So it's mainly I think it's ready for manufacturing. It's a description of what you're building, who are your end users, what's your parts, giving all the. So it's actually, this PRD is before manufacturing. So it's if you're doing, for example, before you're starting doing design for manufacturing, before you go, I don't know, to companies. There are a lot of companies in China and I think in Europe as well who are doing design for manufacturers. But before you go into them, you get this product requirement document. So if you already have functional prototype, you go to this company with a product requirement document, which is what's made of, what's your preferred bill of material, how it works, what's the functionality, all the features, what needs to be done. So really like step by step, how it needs to be assembled as well. It's assembly in the end. So I think you can Google and you can find all the list of things that should be done in the product requirement document. But then after, sorry?
Is it in somewhere in your source of information which you provide for, or it is just in Google? We can find definitely the acknowledgement and the content, what has to be the critical parts of it. Because to my understanding, for the prototype, it's more shorter document, less descriptive, and for the manufacturing is much more deeper.
So for product requirement document, I think you can just Google. I can give you. Principle, I can put.
Give a couple of links which you think it's much more feasible and relevant for.
It's even on Wikipedia.
Okay.
So yeah. But then after doing DFM, design for manufacturing, you will have much more precise. So you'll have all the Gerber files, you'll have all the electronic schematics, you'll have all the firmware, you'll have all the, well, maybe not all the firmware, maybe you don't want to share it, but you'll have all the mechanical designs, all the step files, how, again, the assembly, So, I mean, all the files that needed to be used for manufacturers to develop something. But for manufacturers, actually, you will need, it's a different thing because you will need to change your mechanical parts into plastic molded. So you will need to redesign them in a way so that they can be plastic molded. So there's injection points or some other things. So it's you cannot just go from a 3D printed device and then go into plastic molding. It should be a lot of redesigns usually.
Okay, can it be like a in between of prototyping and manufacturing some kind of simulation? I mean that I don't know, virtual type of manufacturing or prototyping with the simulation approach, or for any kind of client or investor, it would be better to have some kind of real prototyping.
I didn't completely understand the question. So,
for example, we are producing for the plane some kind of part of the plane, so we can do the that part, you know, and create. It's quite like one more big things, you know, and some prototype of that, or we can do the simulation. So we can do some kind of lab conditions where we provide the physical pressure and, you know, the wind type and others, you know, where it would be simulating through the machinery, not the real one. How the investor are paying attention to that. So do they prefer real one or simulation? They believe in the simulation one, especially from the engineering side. I mean.
Well, it depends. Again, investors, for some investors, if you're building turbine, they don't need to see the turbine. They need to see that you have a customer that would like to buy your turbine, for example. So you can show to investors that you have a engineering
preliminary memorandums or something like that.
Or for more like if you're talking about wearables, or if you're talking more about consumer-facing devices, or even enterprise, but for people, then they will want to see certain product that they can try. But if you're talking about much larger things, then I don't know, but I don't think they would like to see the turbine. It's more important if you have a contract with Boeing or Airbus, or interest or letter of intent from them.
Okay, any questions from anybody else? No. So then we don't have more questions. So just check regarding the Kharkiv some questions. Yeah, I don't see any questions by now. Yeah. Okay, so then Ivan, thank you very much. So would appreciate if you can share the presentation so we can share the source of the information. Thanks for your time. Appreciate that you shared with us, and for the rich content. Thanks a lot.
Pleasure.
Yeah.
Hope it helps.
Have a nice,
yeah.
have a nice evening then.
Thank you.
Thanks a lot.
Bye.